All right, let's try and prove that some quadrilaterals are parallelograms. And really, this isn't super involved as far as proving is concerned. So we know properties of parallelograms. We know that opposite sides are parallel. We know opposite angles are congruent. We know the diagonals bisect each other. We know the sum of all the angles is 360 degrees. And we know that adjacent angles are supplementary. Well, the question is, which one of these properties can tell us definitively that the shape that we're given is a parallelogram? Well, if opposite sides are congruent, what other shapes have opposite sides congruent? Well, rectangles have opposite sides congruent. Rhombuses have opposite sides congruent. Squares have opposite sides congruent. Parallelograms have opposite sides congruent. I'm thinking in my head of any other shapes. I don't think there are. Well, the cool thing about those four that I just said, the rectangles, rhombus, square, and parallelogram, they're all parallelograms. A rhombus is a parallelogram, a rectangle is a parallelogram, a square is a parallelogram. A parallelogram is just sides with opposite sides parallel. And all those four shapes have them. So, if I can say that opposite sides are congruent, then it has to be a parallelogram. Now, opposite angles are congruent. Let's ask this. What shapes do we know have opposite angles congruent? Now, I should specify all opposite sides are congruent, because I can have a trapezoid with one pair of sides congruent, one pair of opposite sides congruent, and the others are not. So as long as all opposite sides are congruent, then it has to be a parallelogram. If I know one pair, not enough information. If opposite angles are congruent, and again, if all opposite angles are congruent, both pairs of opposite angles are congruent, do we have to have a parallelogram? The bells are still on. And my train of thought's gone. Okay, all opposite angles are congruent. Can we have a shape? Well, let's think. What shapes have all opposite angles congruent? A rectangle, they're all right angles, and a square, they're all right angles, so all opposite angles are congruent. A rhombus has all opposite angles congruent. A parallelogram, obviously, because we're talking about parallelograms. Kites, no. Trapezoids, no. I think that's it. So it's again those four. So as long as all opposite angles are congruent, it has to be a parallelogram. Now, the diagonals bisect each other. Well, which shapes have diagonals bisecting each other? Well, rectangles, yeah. Squares, yeah. Rhombus, yeah. Parallelogram, obviously, because we're talking about properties of parallelograms. Trapezoids, sometimes, but if they do, it's a parallelogram. Kites, if they do, it's a rhombus. So, yeah. If diagonals bisect each other, it has to be a parallelogram. How about if the sum of all the angles is 360 degrees? Well, that's all quadrilaterals. So yes, that's a property of parallelograms, but that does not help us determine if the shape is a parallelogram. If adjacent angles are supplementary, there is one example, and all I need is one to disprove this. In trapezoids, adjacent angles are congruent. I'm sorry, supplementary, as far as the angles on the two bases. So if I have a trapezoid that looks like this, these two angles are supplementary, and these two angles are supplementary. So, I mean, we could specify this a little bit more specifically to make it so that it works for parallelograms. So maybe I could say every pair of adjacent angles are supplementary. But if I just know that these two are supplementary and these two are supplementary, that's not enough to tell me if it's a parallelogram or not. So I would say this one does not work. If you very much specify, if you say every pair of adjacent angles is supplementary, then yes. But as far as saying that just adjacent angles are supplementary, I mean, we could just say every pair. So there's two. This doesn't work by itself, but if we say that every pair, or all pairs, of adjacent angles are supplementary, then it works. But if we're just saying, again, like if opposite sides are congruent, if all opposite sides are congruent. If it's just one pair, it doesn't work. But if it's all opposite sides are congruent, then it's good. If all opposite angles are congruent, then it's good. If both diagonals bisect each other, then it's good. If adjacent angles are supplementary, if all pairs of adjacent angles are supplementary, then it's good. Yeah, I'm pretty sure that's it. Yep.